test cases for cash withdrawal system, assuming
Oh,
all customers are not allowed to withdraw more than 9,200 a week and 1 million in a month.
was it 9,200 I put there? But it should be 200,000. 200,000, a minimum of, assuming that all customers are not allowed to withdraw more than a minimum of 200,000 and a maximum of 1 million.
1 million in a
Yes,
month.
that's what it
Okay.
should be. So sorry about that value. So I know some people will have had issues with that. So minimum shouldn't be greater than maximum. 9,200 is much more than 1 million. So there's a mistake there. It should be 200,000. So last week we talked about testing techniques, and in some of the things we mentioned last week, we talked about boundary value analysis, right? If you recall, we talked about equivalence partitioning, we talked about decision tables, transition testing, and all of that, right? So also I asked you to do some research on test case document, test suits, and some other terminologies. All right, so now there is a condition given here. We said this customer or all customers, okay, so we are assuming that all users will have a minimum of what, 200,000 to withdraw from their account in a month, and they have a maximum of what, 1 million to withdraw from their account. That is the first thing that you should get right. That's number one. All right. So number two is you have to check that they cannot withdraw, all right, more than what, the maximum value in a month. What is the maximum value? 1 million. All right. So check that they cannot withdraw more than what, 1 million, which is what, like the maximum value. All right. So before I move on to minimum maximum value, the first thing we said 2 weeks ago that you should write a BRD document on an ATM automated teller machine software application, right? So, and in your BRD, if you did your homework well, you discover that an ATM machine performs different functionality. Okay, so while trying to go through your assignment, I've noted some points. All right. So we said the ATM machine should be able to what, create a pin for customer. Customer should be able to what, create a pin. That's number one. That's one of the functionalities of what, of an ATM. So let me share my screen and start typing it out so that we can all follow. We can all follow through with this. Okay. Mm. I want us all to contribute to this one that the class is quiet. I don't. So today is for like okay. So we need feedback from everybody. Right. Okay. People are still joining. Mm. Can you see my screen? So
Yes, we
this
can see
page
it.
I open is
Yes.
just a rough sketch. So I want to
Yeah.
be talking, but I don't just want to be talking. I want you to be seeing my screen as I type down stuff. Okay, so we said that you should write a BRD document, and so in a BRD document, of course, you should know about functionality. So we said an ATM machine software. Okay, so that is the name of the application. Okay, so that's the name of the application. And what the first thing it should be, what, background. So there should be a background to this what, ATM. And what is background? Background is like you describing in and out of what this software does. So what is an ATM machine? So it's going to be like, you describe the entire software. If there has been a prior development, or if this is just an upgrade to the ATM machine, that means that you have to indicate in your background that it is an upgrade. All right. So we have description. We have description under background. We have version history. Then you have okay. Then you have the present, or what will I call it now? Um, New features. Okay, so for these new features, that's what we'll be talking about now. Under that, for BRD, let me just title this so that you don't start looking at it like it's not a test case. This is like a BRD. Okay. Okay. For what? So I said you start with a background knowledge of ATM machine, make it descriptive, include the version history, and then the new features that should be added. Now, talking about functional requirement. Now, we said what are the things that what are the functions that an ATM machine can perform? All right. So I don't want us to go in deep. I just want us to do the usual thing in the perspective of for a customer. For a customer. All right. So number one, yeah, I noted this. Create what? Pin. Change. So this one will be create credit card pin. Okay. Change credit card pin. Okay. What other thing? Withdraw cash. Okay. Deposit cash. Check account balance. Okay. Create bank account. And retrieve credit card. Um, um, okay. So there's also another one. Is it credit transfer? How do you put that word if you are doing a transfer to someone from your account to another account? Can someone tell me? Hello, are you there?
Funds
Remind me now.
transfer. Funds transfer.
Transfer.
Funds.
Yes, fund
Funds
transfer.
transfer.
Okay, great. Okay, so I think you can also do some other things like loading of recharge card. All right. Let me do that one. Load recharge. Then all these subscription services. Let me just say subscription services. Subscription services, talking about DSTV and all of that. All right. So all of these things we know that it's been done by ATM machine, but the ones that it's very popular that you always do every day, Like when you go to an ATM machine, you already know what you will do. That's what withdraw cash. And that was why I gave you that last week. So I gave you um this particular one last week, giving a condition. Now, I didn't say we all know that there are levels to withdraw of cash from the ATM machine, or even attached to individual accounts. There are different kind of accounts: individual accounts, corporate accounts. We all know that savings, current, this, that, and there is always limitation to all of those accounts. All right. So and if you have set certain limitations for your account too, you will discover that per month that you can withdraw up to some amount, per week or per day you can withdraw up to some amount on your account. All right. So for this particular scenario, we are saying that there is a limit. What is the limit? A minimum of 1 million. Okay. A maximum of 1 million. So the first thing you are supposed to do is to, when you have cases, I'm sure by now you know
Excuse me, ma.
scenario and test case. So in case you don't understand, I'm going to explain. All right. Okay.
Hello, ma. Can you hear me?
Gambo Yusuf, can I continue?
Yes, ma. You said a customer cannot withdraw more than 200,000, I think, weekly. Then that 1 million monthly. That was the question.
Was it weekly? I thought I said monthly. Who gave me? Can
Oh,
somebody
I.
read out for me?
Oh, let me check.
You
Let me
said
check now.
Please read out.
200,000
Please read out
weekly,
the
1
assignment.
million monthly.
Yeah.
Okay, so we
Hello?
said 200,000 weekly, right?
Yes.
Yes, ma.
Weekly, yes, 1
Weekly.
million monthly.
Okay, ma.
Weekly.
Hello.
Yeah, I
Hello,
can
ma.
hear you.
Yeah, if we're going to use like 200,000 weekly, that means at the end of the day, if we have 4 weeks in a month, we'll be withdrawing maximum of 800,000 monthly. So,
No,
Yes.
she said maximum of
Let me look
200
for,
weekly.
you
a
know
week,
what? Let me look let me look for the assignment. All right. Maybe the assignment last week.
is-
Okay. So research and create test scenarios and test cases for cash withdrawal system. Assuming all customers are not allowed to withdraw more than 200K a week. Okay, a week. So I said 200K a week. Sorry. So meaning that in a week, in a week, all users should not be able to withdraw more than what, 200K. Okay. So more than 200K in a week, and what? And 1M in a month. Okay. In a month. 1M. Okay. Okay. So if in a week you're only allowed to withdraw 200K, all right. So if you are to write, so there are two scenarios here. So one is what? Cash withdrawal, weekly cash withdrawal. I wanted to define scenario for you the other time before you asked your question. So weekly cash withdrawal and what? Monthly withdrawal. Okay. So I said test scenario. Test scenario is like a process flow. It's an action that a user is supposed to perform. All right. It's also show the process flow of a particular function. So that is what a scenario is. And within a scenario, you can actually have more than one test cases. So those test cases are those test cases are the individual actions that will be performed within that particular process, which is within the scenario. All right. If you are saying right now the scenario is go to market. All right, go to market. So if you are going to market, how do you get to market? The first thing is what? Enter a car or something. All right, enter a car, drop from the car or highlight from the car. What else? And so on. All right. So the fact that they enter a car, highlight, they are what? They are test cases for what? Going to market or purchasing something from a market. So we have just one scenario of going to market, and we have like 2 or 3 test cases attached to it. That is how scenarios and test cases, that's how they work hand in hand. All right. So for this particular assignment, from what I see here, we have this scenario, which is like scenario. Let me put it there. Test. Okay, so which is like weekly cash withdrawal and what? Monthly cash withdrawal. So for this weekly cash withdrawal, we said that in a week, customers should be able to withdraw a minimum of what? 200. If I'm getting it wrong, let me know. Okay. So customers should not be able to withdraw more than in a week, right? Should not. Is it should or should not? It is should not too, because I think I said should not. Should not be allowed. All right. Should not be allowed. That is the grammar. All right. So in a week, customers should not be allowed to withdraw more than 200K. And what should be the minimum? What do you think should be the minimum for weekly withdrawal? All right. So let's assume that weekly withdrawal is from 0 to between 0 and what? 200. So you can withdraw 0 between 0 to 200. So looking at from how we calculated boundary value analysis, or how we did boundary value analysis last week, all right, we said that boundary value consider values within what? The minimum and the maximum values, and every other values outside of the minimum and the maximum remains invalid. All right. So we said minimum. So how do we write test cases for this now? For this minimum 0, how do you think I should write it? So we say verify and validate that customers can make cash withdrawal. Yeah, customer can wish a cash withdrawal. That's the first thing you check for. For all of your scenarios, the first thing you check for is, can we even make any cash withdrawal at all? Can you mute your microphone? Busola. Okay. All right.
Sorry, I muted it.
So I said for every withdrawal, for every scenario, you have to first check that you can even make a withdrawal. All right. So the first thing is validate that customers can make a cash withdrawal. Note that. All right. So what should be the next thing? Validate that customers okay, cannot withdraw more than 200K weekly. Am I right? All right. So the last one will be what? Validate that customers can withdraw up to 200K weekly, or you can say a maximum. Can withdraw up to or can withdraw a maximum of 200K weekly. So there you have it. Do we understand? Hello? Does someone
Yes, ma, we understand. Yes,
Yes.
Okay. All right. So you do for monthly also. So this is going to be monthly cash withdrawal. And then you write your test cases. So we also said that in a month, customers should not be able to withdraw more than 1 million. All right. So more than 1 million should not be able to withdraw more than 1 million, meaning that what is the minimum? Someone should tell me what's the minimum value here, what is the maximum value here?
Minimum value is 200,000. One maximum value is 1 million.
Okay, someone else?
The minimum is 0, while the maximum is 1 million.
Someone else?
Minimum is 0 and maximum is 1 million.
All right. Who else? A contrary opinion?
No.
All right, let's visit the question again. So we said assuming all customers are not allowed to withdraw more than 200K a week and 1M in a month. So they are not allowed to withdraw more than 1M in a month. You are not allowed to withdraw more than 1M in a month. Maximum value is 1M in a month. So you are not allowed to withdraw more than 1M in a month. So what we are considering here is what? Monthly cash withdrawal. So what do we have here? 0. All right. You don't have 200 here. What you have here is 0. Why? Because you have already analyzed for this, and this is supposed to be for what? Weekly withdrawal. All right, let's continue. So for this zero now, first you validate that customers can make a cash withdraw. Withdrawal. That's the first thing. What is the next thing? What else will you do? Number one. Let me put this as number one. Number one. Two. It's also like that. Validate. But I'm going to check another scenario. That was the one I wanted to do earlier before you told me that it is supposed to be weekly and then monthly. So we'll do that one. But let's complete this first. Validate that customers cannot withdraw, more than 1M monthly, right? And what is the maximum? Validate customers can withdraw up to 10 monthly. Okay, so that is for this scenario we talked about. Let me highlight it so that we don't get confused. Okay, so we said assuming this is the question. So cash withdrawal, cash withdrawal. Assuming all customers are not allowed okay, what if it is assuming so what if it is assuming all customers are not allowed to withdraw more than this a week, more than 200k in a week with withdraw more than withdraw more than 200k a week, and this a week, let me make it a month. A month. All right. So assuming this is the question that was given, assuming all customers are not allowed to withdraw more than 200k a month and 1M in a month, what should we do? Okay. So we analyze that too. So what we have now is just one scenario. We have one scenario, which is a monthly scenario. Okay. We have one scenario, which is a monthly scenario, that is saying that assuming all customers are not allowed to withdraw more than. So here we have a minimum value, a maximum value. What is the minimum again? 200k a month, and a maximum of 1M. So I want us to Give me the test cases under the scenario. Give me the test cases. This one is going to be interesting. Okay. So, number one. So who is ready to give me the test cases? Okay, so one test case per one person. Let's go. The
Hello, ma.
first test.
Okay.
Hello.
Uh,
Yeah.
from
Did
the
you see the scenario? I
the
assuming all
scenario,
customers are
Yeah.
you said 200K monthly and 1 million monthly.
yes. That's the minimum amount you are supposed to withdraw is 200K and the maximum is 1M in a month.
Okay. Yeah, the first test case, which is the minimum is going to be 200K. That's the first test case.
Okay. So you are saying that validates that customers can withdraw a minimum.
No, the first test case that is going to be here is you first validate that customers cannot withdraw less than 200K in a month.
Okay. Validate that customers cannot
Withdraw less than 200K.
withdraw less than 200K in a month. Good.
And
All
then the
right.
second,
Number two, someone else. No, let someone else talk. All right. So someone else should pick it up. We are saying that in a month, the minimum amount you're allowed to withdraw is 200K and the maximum is 1M. So how do you want to write these test cases? All right. Someone else. Should I start calling him? Victory. Victory, are you there? Adekemi, can you give us one test case?
Okay, ma'am.
All right.
Sorry, a minute. I got called by someone. So, what is the question again? Sorry.
Okay, so we are giving a different scenario now. So I
Okay, ma'am.
said, assuming the scenario is a monthly withdrawal of a minimum of 200K and a
Okay.
maximum withdrawal of 1 million naira. So how do you want to write your test cases? A
Okay.
minimum of 200K and a maximum of 1M.
Okay. So, validates that customers should be able to withdraw between 200 to 1 million a month.
Validates that customers should be able to withdraw within 200.
200K to 1 million in a
Okay.
month.
Validates that customers should be able to withdraw two hundred k in months. Okay. Someone else. Thank you.
Validate that the customer cannot withdraw more than 1M.
Yes. Validate that customers cannot withdraw more than 1M in a month. All right. Number four.
Maximum will be 1 million.
Okay. So how do
So
you write that?
to validate that customer can only withdraw up to
Okay.
1 million monthly.
Okay. Validate that customers
Can only withdraw
can only withdraw.
1
Okay.
million monthly.
Mm,
Or say can only withdraw not more than 1 million monthly.
maximum
Mm,
of 1 M.
monthly.
All right. Number 5. Do we have up to 5?
Hello?
Yes.
Hello, ma. Yes, ma. Yeah, I want to ask if this is a test case, for example, if you like want to validate if customer can actually withdraw cash within the range of 200 to 1 million. Like the customers
Okay.
can actually withdraw cash. Is it a test case?
You are talking about number 2.
No, I'm just feeling like the first one, if customer can actually withdraw cash within the stipulated range.
Okay, that's it. Yeah. This is the range, yeah.
Okay. Okay.
Right?
Yes, ma'am.
So this is the stipulated range. This is the one outside of the minimum. This is the one outside of the maximum, right? And this is the maximum. All right. So we have in these 4 test cases, we have minimum, we have maximum, we have the range that's within the minimum and the maximum range. And then I'm thinking there should be one. There should be one. So after validating your values, you will still say, just like I put there number 1 the other time, you're still going to say validate that customers can withdraw withdraw cash. Validate that customer can make a cash withdrawal. Can make a cash withdrawal. So the first thing you check for is the function of cash withdrawal. Can you withdraw at all? After that, you start checking for the specification. And what is the specification? Minimum of 200K, maximum of. So the function, the real function is cash withdrawal. Can the customer make a cash withdrawal? That's the first one. Then the second thing you consider is the specification. Can they make cash with a minimum of 200K? Can they make a maximum of 1M? Then can they withdraw any other amount within the range, that is 300, 400, 500, and so on. So that is your test case, and that is how you properly test for that. All right. Um, I think that is all for this particular question. Now, if you have more questions for me now, assuming when some people were fleshing out their BRD the other week, they really, some people did really good job. All right. So we all know that I don't know if you have done credit card change of PIN or something, or creating of PIN on ATM before now. So they really fleshed it out, saying that users should be able to insert their card. There should be an interface where user will enter their card PIN. All right. There should be an interface that asks user to submit. There should be a submit button, and then there should be this one and that one. That is how they flesh it out. But right now, all that we have here are just the basic functions of this particular software. So the way I wrote this thing today, I wrote it based on process flow. All right. So when we go into today's teaching, you will understand more about test strategy. All right. So let's continue. But if you have questions for me, though, if you have questions for me regarding writing test scenarios and test case, we can also still go there. But I have a big assignment for us this week, and that's why I've grouped us into different groups. So I want you to work together to be able to do the assignment. All right. So you work together to. This is for last week. Yeah. Okay, so this is this week's training. So if you have questions, just keep it after this class. Who knows, you might get your answer in this class, and then after this class, if you still don't have your answers, then I will answer your question. But for now, let's just move on to this class. So today we are considering test management. All right, and that consists of test planning and estimation, test monitoring and control, then defect management. How do you manage your defects when you have executed your test cases and you've seen defects, a lot of defects, you've noted them down? How do you manage them? All right, and how do you retest to ensure that those defects does not reoccur? I mean, that's the essence of defect management. All right, so starting with test planning and estimation. So we said the other day that um your work product consists of um your test plan document, your BRD document, BRD or FRD, or whichever name it is called, your process flow document, your test suit. Your test suit is a collection of your test cases, your artifact, which is like the screenshot of where defect is taking place. Sometimes when you discover defects, you have to screenshot them. So these screenshots or these images, they are also called artifacts. All right. So your test suit consists of your artifacts, your test cases, your defect log or your error log. All right. So and so on, including the names of those who executed the test, that's your team, and then the test summary also has the test summary. All right. Or the test results. So that's is a collection. That's why we call it test suit. But before you start testing your application, the moment the software or the function is ready to be tested, all right, there is a need to prepare the test plan. So the test plan is a document, all right, that will outline all the test activities that will take place for that particular application on that test. So planning is influenced by test policy and test strategy of the organization, the development life cycle and methods being used, the scope of testing, objectives, risk, constraints, criticality, testability, and availability of resources. What you are checking for when you are planning is you are checking, do we even have people that will test this application? All right. You are checking for resources. You are checking for the risk attached to that application. How vulnerable is this application we will be testing? All right. Will it involve security test? Will it involve performance test? Will it involve automation? All right. You are checking for the different kind of tests that will be conducted on it. Also, you are checking the scope and the objective. You are checking if there's any constraint of any kind. All right. So in your test plan, you have to align the purpose of the software or the document. All right. You have to outline the scope, outline the resources that will be testing them. You have to put your timeline also. Okay, from when to when will this execution be taking place? Test execution will be taking place. How many test cycles will be conducted for this application. All right, you have to put everything there. So at this level, in some organizations, the junior tester or the interns, they don't engage in writing the test plan. People that write them are the mid-level software testers, senior level, and managers. They write the test plan and review it, and then they pass it on. All right. So we have the test plan. It outlines the budgeting. All right. Outlines how the test will be carried out, monitored, and controlled. All right. Scheduling for test analysis, design, and implementation. Usually, so you, by now you'll be thinking that, so if we want to do any test on any application, we'll do test plan. Oh, that can be too much and all of that. Usually there is test plan, so you don't have to like give yourself any idea. There's always, I said test plan, there's always template. Sorry. Usually there's template. Every organization have their own template, have their own formats to which they design their test plan. So that template, each time they just want to start any testing process, what they do is they edit it. They change the teams that are being involved, change their names, change the name of the software, change this, change that. So all they do is just to edit. All right. So they have the template already designed. All right. So there's usually test plan. And let's continue. Now, also, before you start testing, you have to map out a strategy. All right. So a test strategy provides a generalized description of the test process, usually at the product or organizational level. So we have an analytical method, model-based method, we have methodical method, we have process, all right, process compliance, we have direct, and we have regression averse. All right, all of these things, you just have to take notes of them. Most of the time you need testing strategy when you are dealing with big softwares, big application, especially the ones you've not tested before, or the ones that were performed and they were done before you got there. If you are new to an application, sometimes you need to do a test strategy, all right, before you start testing, unless you're already used to the application and you know the ins and the outs of such an application. All right. So we said analytical is a type of test strategy that is based on the analysis of some factors like the requirement and the risk. And risk-based testing is an example of an analytical approach where tests are designed and prioritized based on the level of risk. So based on the level of risk, you analyze the software, the test that will be performed, and then you strategize on how you want to approach your testing. There's also model-based. Said in this type of test strategy, tests are designed based on some models of some required aspect of the product, such as function, business process, internal structure, and so on. All right. So what we are saying is that based on the model of the software, some softwares are different. Like the example of the assignment we just did, all right, is an example of a software that requires user input and then output. There are some softwares that does not require user entering in values and then checking for the output in that manner. For example, if you are testing a form, let's say a registration portal, where you have to deal with large forms, you enter, you input information, you upload pictures, you attach documents, and you do all of that. The way you're going to test that application, for example, is different from the way you are going to test this cash withdrawal system, which we just talked about. So all of these softwares, the way they are designed, the way they are built are different. So when you are strategizing on how to conduct your tests, you are also looking into how the software was designed. All right. So we say this for methodical, it has to do with a systematic use of some predefined set of test or test condition, such as taxonomy. Taxonomy is like the name of the product, all right, and likely causes of failure, all right, a list of important quality characteristics a company while look and feel standard for mobile and so on. So I think you can use methodical when you are talking about some kind of mobile application. You know, when you are testing some mobile application, you are considering the storage effects, all right. There are some times that if you want to update your profile image on some mobile apps, you can't upload more than 1 MB or 10 MB or some or KB or something. All right. So they've streamlined it such that you can't do something more than that. Why? It is because of the storage effect on how it was designed, or some other forms of design. You know, some mobile applications also has to deal with splash pages, which you don't see in a web application. All right. So if you go to a web application, sometimes the only thing you see is just the landing page, and then probably the login page and all of that. You don't see splash pages. I don't know if you understand what I mean by splash pages. Splash pages are just like static pages where user does not have to perform anything on the mobile app. They are usually on mobile app. All right. The method in which you're going to test this kind of splash page is different from when you are testing its variant on the web. All right. So you have to consider your stress your test strategy and the kind of application you are testing. All right. The one I was talking about the other time is process. All right. When I was talking about how we design that test case for cash withdrawal. All right. So process compliant or standard compliant, this type of test strategy involves analyzing, designing, and implementing tests based on external rules and standards, such as those specified by industry-specific standard, by process documentation, by rigorous identification, and by use of test basis, by any process or standard imposed or by... So what is test basis? Can anyone remind me? I just want to know if you've been following through with this class. Test basis, please. Test basis, an example of test basis too. Someone please tell me, what is test basis? If you can recall. I'm listening to you. Test basis. Don't check your book. Oh. Anyone?
Is the source of information or the document that is needed to write a test case.
Okay, example. Example, we've mentioned it severally in this class. Example of a test-based document. You know, test-based is one of your work products. Your BRD, your SRD, your process flow, your designs, your workflow diagrams, right? That's your test basis. Okay. So process compliance, it will, if you are designing a strategy that is process compliant, sometimes you use your test basis to design such a strategy. And that was what I was looking at the other time. I was highlighting functions of of what's the name of an ATM application. After highlighting the functions, then I was able to bring out one of the functions. All right, I was able to bring one of the functions, and then I highlighted the test cases for that function. That is process compliant. So if I'm to design a test strategy for this ATM software we just finished, I will use what? A process compliance. Why? I have my BRD, all right, and the process for designing an ATM, I mean the way an ATM is designed, it is process compliant. All right. So if you look at the definition of process compliance, you see it says this type of test strategy involves analyzing, designing, implementing tests based on external rules and standards, such as those and their rules. All right. So let's continue. We have directed or consultative. So this type of test strategy is driven primarily by the advice, guidance, or instruction of stakeholders, business domain expert, technology experts who may be outside of the testing or outside of the organization. Then we have regressive averse. This type of test strategy is motivated by a desire to avoid regression of existing capability. This strategy includes reuse of existing test wares, especially test cases and test data. You already know what test ware is, am I right? So all of these terminologies, please, I need us to note them, because you will hear people mentioning them, and it won't be strange to you. All right. So extensive automation of regression tests and standard test suite. So what the strategy they are trying to, for regression averse, what they are trying to say is, for softwares that easily regress, all right. Easily regress means that if the software is prone to defects, or certain functionalities there keeps breaking, all right, when you will design your strategy, you have to consider regression averse method. All right. So, and when you are considering regression averse method, you are taking note of automation. All right. You are taking note of automation. You are taking note of a standard test. You have to have a standard test suit. You have to make use of automation. You have to do this and do that. All right. So strategy is important before you start testing your application. Let's continue. Okay, so we have entry criteria and exit criteria. Also, I forgot to tell you, in your test plan you have to put entry and exit criteria. Entry and exit criteria is telling us that what are the conditions before we start testing this application. Exit says the conditions before releasing this application. All right. So entry criteria defines the precondition for undertaking a given test activity. If entry criteria are not met, it is likely that the activity will prove more difficult, more time consuming, more costly, and more risk. The other day we said the more time you waste, the more the money you waste. All right. In testing, the more the time you waste, the more the money you waste. All right. So we are saying that, so it is better you strategize. It is better you slowly or painstakingly put down everything in your test cases, follow the process, than you rushing through the process and at the end of the day coming back to do the same thing. So what do we do? Follow the process. Entry criteria are conditions before you start testing. Ensure that those conditions get fulfilled. What do they include? It includes testable requirement. That is, now you have your PRD, you have your user story, you have your use cases, you have your model diagrams, your process flow diagram, your workflow diagram, your product designs, UI, UX, your Figma diagrams, and so on. You have things you can use to design your test cases. All right. You have your test cases, your test suits, and all of that. So before you enter, or before you can say an application is even worth your attention to start testing, you need to have those requirements. So in your plan, you are stating it for them, for stakeholders. You are stating it that, okay, entry criteria to start testing this application is number one, BRD. Number two, environment, test environment, test tools, test data, and so on. All right. So test environment is saying that, okay, there is a provisioning of where, or there is an environment that is meant for testing that you can access. All right. So the application is there and on the test environment, and you can access it. All right. They've made provision of for test data that you can use. You can use them, you can access it, and now you can test. So it's a condition in your test plan that before I start testing, please make provision for. Don't say, oh, it is still on the developers local system. It doesn't make sense for it to still be on the developers local system. That means they are not ready to start testing. All right. When they are ready to start testing, they will push it from the developers local system or from the repo, wherever repo it is, dev repo, and they will push it to a testable environment. All right. So do we have the necessary tools, and do we have the necessary test data? All right, and the resources. Then if all of these conditions are met, then we can start testing. All right, that's what test entry criteria is. An exit criteria is talking about conditions that must be met before you release your application. All right, before you push it to production environment. Okay, so and it happens after testing, after executing your test, and after you have your test results, and when your test results has met the conditions. So you could the exit condition might be, oh, test result has to be 99.99% passed. All right. It has to it must have a defined level of coverage, like I said, maybe 99.99% passed. All right. So it must have met all the acceptance criteria. Acceptance criteria requirements, or that each of the functions. Hello, so sorry. I think it was my network. So can you all hear me now? So I was saying something about the exit criteria. I said there are conditions. One of it is all the test cases has been executed. It has met a level of coverage. Number of unresolved defects is within agreed limit. Maybe we have agreed that unresolved defects that are low, that are not critical, even if there are low unresolved defects, we can still push this thing to life. Yes, it can also be an exit criteria. All right. We said the other day the 7 principles of testing. Can you remember? 7 principles. One of the principle, can someone
Yes.
remind me?
Pesticide paradox.
All right, the specified paradox. What about the one that relates to exhaustive testing? Exhaustive testing is what?
Safe testing, yes,
Impossible. All
it's
right.
impossible.
So yeah, so that is it. So if in sometimes when they are writing exit criteria, they can say, okay, for defects that are within the low level bracket, if they still exist at that stage, then they can still go live. All right. It does not affect going live for that application. It does not affect pushing to production. It is exit condition. All right. So number of unresolved defects, number of estimated remaining defects is sufficiently low. The evaluated levels of reliability, performance, efficiency, usability, security, and other relevant quality statistics are sufficient. All right. So what we are trying to say is, for that condition, for that software, mind you, everyone have their own defined exit criteria. It's different in different places. So I can say that for this product, this is what I want. This is the exit criteria. All right. Usually, who defines the exit criteria is the product owner, or sometimes the test manager, or the business analyst. All right. They define the exit criteria. If it is up to this level, we can still go live. So when it gets to that level, even if the defect is still there, if so far the level is low, it's not critical, it's not going to affect the application when it go live, then you can exit testing. All right, let's continue. um We have test monitoring and control. So there are certain metrics that is used to control or to monitor the testing process or the testing progress. So progress against plan trying to rush. All right. So we have effectiveness of test activities with respect to objective. Common test metrics include number one, percentage of planned work done in test case preparation, percentage of planned work done in test environment preparation, test case execution, whether it passes or fails, the defect information or defect density. What's the level of, or what is it a critical bug? Is it high? Is it medium? Is it low? You know, defect has their own statuses. All right. So what is the defect information? What is the test coverage? So what we are saying is test monitoring has to do with that that midpoint between where you start testing your application and when the defect is being fixed. All right, when you discover defects and then you push it to developers to start fixing. Okay, so in between we call it monitoring and control, and the things that takes place within that interval we call it test coverage of requirement, test completion, test case execution, and so on. So it is within that time you start running your tests, you start executing them. Now you can see how many iterations you have done, how many test cases passed, how many failed. All right. Now you are fixing bugs, you are sending bugs to developers, they are fixing, you are retesting, you are performing regression tests, and so on. That's the phase you call test monitoring and control. Then while you are doing that testing and control, there's something we call test progress report. So during test monitoring and control, the test manager regularly issues test progress reports for stakeholders. So in addition to content common to test progress reports and test summary reports, typical test progress reports may include, so we know that test summary report happens after testing, after execution, after test results, you know, just before test exits. You do what? You write your test summary reports. All right. But before then, there's something we call progress reports. You do progress reports just to give the status or the progress of of your test to stakeholders, to those who need them. Maybe you are trying to
We can hear you.
hello, you guys cannot hear me? Wow.
I can hear you now.
Yes,
Hello?
ma. Your mic
I hear
was
you
muted.
I hear you now.
For how many minutes? Wow.
for one
Just
minute.
few seconds.
Okay, great. Okay, did you hear anything about test monitoring and control?
Yes,
Yes,
yes.
ma.
Yes, yes.
Okay,
Yes.
okay, I think it was when I moved to this page. All right, so I was talking about test progress report. I said this is the report you give to stakeholders just before you exit your tests, your test phase, your testing phase. So we are saying that during the time when you test, you execute your test and then you send defects to developers, and then they fix and you retest and you do regression and all of that. During this phase there's something called test progress report. Okay, so this is just to give feedback to important stakeholders, understand the state test execution that is being done. If you need more time, all right, or if, they need to change features, add more features, or you understand. So it's a progress report. So in addition to content common to test progress report and test summary report, typical test progress report include the status of test activities, factors impeding progress, testing plan for next reporting period, and the quality of test objects. So quality of test objects is saying that we have more bugs, we have more defects than the tests that passed. Okay, than past test cases. We have more failed test cases than past test cases. So you are trying to report this, or it may also include things that are stopping the progress of progress of executing test cases. All right, probably because it takes more time for developers to fix bugs, and then there is a problem with communication line, or some requirements are not well defined, and so on. So sometimes because of this, you need to write a test progress report so that the important stakeholders are updated on the progress of the test, all right, that is being done. Okay, so the next thing is what? Test summary report. This happens after at test closure. Yeah, it happens at test closure. So your test summary report happens at test closure. At this phase, you've concluded testing, and you are about to check for your exit criteria. At this phase, you're checking for your exit criteria. Are they all meeting the conditions? If they are meeting the conditions, if they meet at least up to 99% of the conditions, then you can write your test summary report. And in your test summary report, you say when exit criteria is reached, the test manager issues the test summary report. The report provides a summary of the testing performed based on the latest test progress reports and any other relevant information. So here you have the summary of the test that's been performed, execution, test results, execution test results. You can see number of past test cases. You can see number of failed test cases. You can see how many iterations were performed before they passed, and for those that keeps failing, you see how many iterations. All right, you also see deviations from test plans. You see deviations from functionalities and requirements. If changing functions of your new changes were added in between the testing process and development process, it has to be there too. You see metrics for defects. How do you measure defects? So metrics for defects is saying that for defects that are low, then they are not of priority. For defects that are medium, maybe they are close, or for defects that are critical, they belong to a priority one, and so on. So there are metrics for checking for defects, factors that have blocked, or there are some test cases that you have to block, probably because they discover that they do not want to implement that function. Oh, this function is not necessary, even though it is in the BRD. Oh, we are not implementing it because we discovered this, we discovered that. So vendor cancelled on us, so we are using another vendor, and so on. So, but you already have it in your test case. What do you do when you want to execute test case? You block it. Why? Because that function has been blocked. It's not part of the software. So all of this thing has to be indicated in your test summary report. All right. So that is what test summary report is. From word summary, summarizes all your tests, that has been all your test execution and all of that. So we have defect management. So what is defect management? Saying defect management is the way you manage your defect, and the way you fix it. All right. So we say, since one of the objectives of testing is to find defects found during testing should be logged. The way in which defects are logged varies. Okay, so also depending on what methodology is being used in some organizations, you discover that some people actually, the way they list their defect, the way they track it, let me say track. The way they track their defect is different. Some organizations still make use of Excel spreadsheet. That is fine, but it can be rigorous at the same time. So, all right, so especially for manual testing, they use Excel spreadsheet. They will have a test case ID. They have defect ID, defect description, and then you have what other thing? Screenshots or artifacts. Where did you notice the defect? Then maybe you screenshot it and then you put it there. Then who noticed the defect? Then you also have product owner. So who will this defect go to after it is noticed? All right, that should be the developer. You put the name of the developer that is working on that function there, and so on. But in some other places, instead of making use of Excel sheet, they make use of project managing tools like Jira. All right, so Jira is being used in some places to track defect. So there, you raise this, they say raise a bug or raise a ticket. All right. So you list all your bugs by creating task and all of that, or subtask, attach it to each task, and assign a developer or whoever is handling it to it. It will also carry description of the defect and reproducible steps. So you have reproducible steps for the defect. You have maybe screenshot of the defect. Then it has numbers like ID to identify the defect. Also, another thing you shouldn't forget is which test case were you executing before you notice the defect. All right. So which test case did you execute? So all of the test case that you executed executed for that defect, you have to indicate it, so that by the time the developer or whoever is reviewing the defect list, all right, they can know where the defect happened, and they can track it down to the test cases and ensure that those test cases were not passed but failed. All right. So the test cases can be 2 3 attached to just one defect. So you have to indicate which test case ID by putting the test case ID. That's the essence of the test case ID. You have to put the test case ID, attach it to the defect, all right, so that they can properly track the defect. That's the essence of defect management, tracking of defects, changing defect status when a defect has been fixed. When a defect is raised freshly and new, you call it new or open. But by the time a developer start working on it and then it is fixed, then you can say what is that status? In progress. All right. It can be put to in progress. Then by the time you retest as a tester and you discover that even though he said he has fixed it or they have fixed it, if the defect still failed, then you can return it back to rework or reopen. All right, you turn it back to reopen and then assign the developer again, add a comment on why it is reopened, and then the developer gets to see it, or work on it again, and then maybe you retest it again. By the time you are retesting this time around, if it passed, you change it to pass, and if it fails again, what do you do again? You reopen it, and so on, until you get to a level where you close it, and then that defect is totally gone. But that means it's closed, you are done with the defect. All right. So that's what we call defect life cycle. So coming to defect life cycle, we say defect life cycle, also known as bug life cycle, is the journey of a defect cycle which a defect goes through during its lifetime. It varies from organization to organization and also from project to project, as it is governed by the software testing process, and also depends on the tools. I said it already. I said depending on the tools being used and depending on the organization. Some people use Excel spreadsheets, others use Jira, you know. Some other people use maybe Adobe, Microsoft, and so on. Different tools, all right. So but the common one is the Excel spreadsheet. All right. So it varies from organization to organizations. The purpose of a defect life cycle is to easily coordinate and communicate current status of defects, which changes to various assignees, and make the defect fixing process systematic and efficient. So defect life cycle, as you can see from here. So when a defect is first discovered, it is new. All right. When it becomes assigned, it is open. And then when it becomes fixed, it is what? Fixed. And then when it has not been tested, after it has been fixed, it's pending retest. When it is being retested, it is at retesting status. When it is verified or passed, and then it is closed. So when it is closed, the life cycle has ended. All right. So just like I said, if it is reopened, then it means that after retesting, you discover that the defect has not been fixed. All right. So duplicate, rejected, deferred. There's also something called duplicate. If the defect has occurred before now, or if there is an ID that has the same defect description, all right, then you do not need to create another defect. And defects can be deferred if they have decided that the functionality has changed, or something has changed, new feature has changed, something has changed within the system, then probably it is not being considered as a defect anymore. Then it is deferred. All right. A defect can be rejected if it is not actually a defect. It is possible to misunderstand how the process work. All right. If you misunderstand the process work and you call it a defect, it can be rejected, and so on. All right. Let's quickly finish before I start answering questions. We said different life states. We have new, we have open, we have assigned, we have active, in progress. I mentioned in progress the other time. We have test, verified. So when a defect is logged and posted for the first time, its state is given as new. Assigned is assigned to a development team. Active means the defect is being addressed or is in progress. Test means the defect is fixed or is in a process of testing. And verified, that the defect that is retested, that the defect is retested and the test has been verified by the QA. All right. So we also have closed, that the final state of the defect that I am defect that can be closed after QA retesting, or can be closed if defect is duplicated or considered as not a defect. We have reopened or rework. Reopen or rework is when, after it has been closed, you discover that it was implemented wrongly. All right. After it has been closed, you discover that it is implemented wrongly, then you have to reopen it. So when the defect is not fixed, a QA reopens or reactivates the defect. Then we also have defer, when a defect cannot be addressed in that particular cycle, or when they have pushed that feature to another version. If you say, oh, we want to quickly release, we cannot implement this feature now, oh, and so on. So when it has been pushed to another version, you discover that um it's possible that you just defer the defect. All right. So put it to or if it is not reproducible, defect. Let me just explain what reproducibility is. So a defect is a defect when it can be reproducible. So reproducible means that someone else can engage with that particular software where you have seen the defect. They can engage with it and they can produce the same defect which you have discovered. All right. You are saying that, oh, for this defect to happen, you have to, number one, access it through Google browser, Google Chrome, log in using so username and password, then click on the home page, then open contact form, then enter description, then click on submit button. So maybe the defect happened at click on submit button. You're saying that on that click on submit button, there is the defect, and you've already added all the steps it will take before you get to submit button. If somebody else does the same process, they must get the same defect that you have gotten, right? They must see the same thing. So you are saying that that defect is reproducible, then it is actually a what? A defect. But if it is not reproducible, then it can be different, and it may not actually be a defect. Let's continue. So defects bug life cycle explained. So this is just an image showing how a defect happens. Tester finds a defect, he opens it, development project manager analyzes the defect. If it is valid, yes, then they work on it. Is it in scope? Yes. Is it ready, or is it already reached? And so on. Then the developer start fixing the code. Then it changes to in progress. Once it is fixed and the status is fixed, then tester start testing the code. If it passes, then it is closed. If it doesn't pass, then it is reopened, and then the process begin all over. So that is just how the defect life cycle happens. All right. Now we have assignment. The truth of the matter is we've been able to cover every manual process for this phase from lesson 1 to lesson 3. We've covered everything from introduction to software testing to methodologies, all right, to types of software testing, to testing techniques, all right, and even to developing test cases, test scenarios, life cycle. Now we have defect life cycle. So now we have a group work. I said perform an exploratory test and prepare a test suit. So number one thing, perform. Wow, thank you. So perform an exploratory test, present a test suite containing test scenario, executed test cases, artifacts, including defect log of your favorite mobile payment application. So the thing here is, I'm not going to restrict you to any particular payment application. So any one of your choice, if it is GT World for GT Bank, if it is Kuda Bank, if it is which one is that one for Wema again, and then UBA and all of that. So look for a mobile payment application that can exist whether on iPhone or on Android. You guys will choose which platform you're going to use, whether it is iPhone or Android. It must be mobile application. Then conduct an exploratory test. You already know what exploratory test is. By definition, you don't need to have an already prepared BRD anyway. You just need to go through it and by yourself produce test cases from it. All right. So perform an exploratory test. Prepare a test suite document containing test scenarios, executed test cases, and artifacts. I mentioned artifact. Artifact, they're like screenshots, test data that were used, and so on. So everything will be included in your test suite. Test suite. So test suite, I will show you an example of a test suite. So I will show you now, after now, of how a test should look like, so that by the time you start preparing your own, you are not giving me 2-3 documents at a time. I need just one document, which is an Excel document, just one document. So inside this one document, which is your test suite, you have everything there. So including defect log. So it will have defect log, it will have test cases, it will have artifacts, it will have test scenarios. So submission date, sorry, I can't extend it. Some people have been asking for extension. That's why I can't grade your work. If it extends to Thursday or Friday, I won't have time to do it. So if I don't know how you want to work, maybe you start the discussion today and tomorrow on what platform you will use. Then from your discussion, right? From your discussion, you can start, you can assign work to each member of the group. You have your group on the Slack platform. Okay, so you can assign work to each member of your group. Then after assigning, then each person can start working on them. So by the time then you can just meet like once or twice to like bring your work together, and then you submit. So you can do it that way, right? So questions, any question for me while I try to look for a test suit that we can use? Okay, Stephen B, you can ask your question.